Hello and welcome back to the session, and we'll be continuing with the solution of question paper. Now there is a another very good thing that is have been introduced in GTU, that right now as you're watching my lecture or as you are attending the lecture, if you have any doubts, then you can go to GTU Knowledge and you can go to live outcome lectures and you can ask questions directly to me, so I'll be answering them. So we already have a few queries which will be we will be answering at the end of the session. So last 10 minutes will be for you. If you have any queries, go to GTU Knowledge and then live outcome, and there you have a form. Just send in the questions, so we'll be answering the questions live. So whatever doubt it is, we'll clear it on the spot as well. So we were talking about question number 2b. A line AB 80 mm long is inclined to HP by 30 degrees and inclined to VP by 45 degrees. It is in the first quadrant. It is in the first quadrant. It is in the first quadrant with point A 15 mm above HP and 30 mm in front of VP. Draw the projection of line AB. So now we have been given a line AB which is 80 mm long, and it is inclined to HP by 30 degrees and inclined to VP by 45 degrees. Now what it is said that the point is in the first quadrant with 15 mm above HP and 30 mm in front of VP. We have to draw the projection of this line AB. So let's see how the projection of this line would be. So first of all, as we always do, we'll first draw the line XY, and now as is denoted, the VP is the blue part and HP is the yellow part. So this is there. Now the next step, we have to mark the point A dash, which is 15 mm above XY, and point A, which is 30 mm below XY. That is the point A, which is 15 mm above HP and 30 mm in front of VP, is being marked on this two-dimensional VP and HP planes. This is 15 mm, and then the straight line which ends up here, which will show 30 mm below point X, below the line XY, so that becomes 30 mm. So these are the two initial points that are given to us. Now the next step, we have to draw A dash B1 dash, which is length 80 mm and length of angle of 30 degrees with respect to XY. So this will be drawn on the above line XY. So first of all, a straight line, that is a reference line, and then angle of 30 degrees is taken, and with respect to that, B1 dash is marked, and the angle is 30 degrees and the length is total of 80 mm. Similarly, for point A, that is below line XY, we will draw AB2. The length will be again 80 mm and angle is 45 degrees, but we have taken minus 45 degrees because it is with respect to HP. Now if you take 45 degrees with respect to HP, then it will kind of become different from what it actually is. So minus 45 degrees with respect to HP is what has to be taken. So this is the reference line again, and now what we'll do is we'll take 45 degrees and 45 degrees and then straight line of 80 mm, which will be marked as AB1, and 80 mm is the total length. So this is the basic thing that is given in the question. So we have arrived to this. Now what next is required is that we'll drop a perpendicular from B1 dash on line parallel to XY through A. So this is what we will do. The point will be dropped as this. From B1 dash, we have dropped a straight perpendicular to point B1, and similarly from B2 we will draw a straight perpendicular on A dash, which is line B2 dash. Yeah, done. So these are the two projections that we have drawn. Then the next step, now the locus of B1 dash and B2 dash has to be drawn. That is these points B1 dash, this is the point. The locus will be drawn as a straight line, and B2 will be again a straight line. This we have discussed before, that if a cone, if you see a cone, and if you rotate the cone, if you rotate a line about a point like a cone, then the locus would be a straight line. That is, the top part would be a straight line, because it will basically form a circle, and if you look it from the front, then it will be a straight line of equal to the diameter. Now we'll just draw the locus as a simple locus, so that first on B1 dash and then on B2. Now this locus is very important, as this will be housing the endpoints of the projectors, the projections, that is the top view and the front view, or you can say both the views will be marked on this focus. The endpoint will be marked on the focus. So how will we do that? The endpoints that we have drawn, that is B1 and B2 dash, will be of utmost of importance. So we'll take radius equal to A dash B1, and the center would be A dash, and we will cut an arc on the locus. That is, the radius would be from here to B1, and then we'll take an arc and cut a line here. So this is what, and this point comes down to as B dash. So then what will happen is that A dash will connect A dash B dash, and as we know, on vertical plane we always have the front view, so FV would be our front view. Now the next step is this, will do the same thing for getting the top view as well. So the distance will be equal to AB1, and AS center will cut an arc on the locus, that is through locus of B2. So this is how the line goes, as you can see, and the point will be generated as B2, only B, and then we will join the line AB to have the top view. So in the figure, A dash B dash we have the front view, and AB we have the top view. So this is the solution of the problem which is there, question number 2B. Okay, the next is question of planes. That is, a circular plate of negligible thickness having 70 mm diameter is resting on HP on a point of circumference. Plate is kept perpendicular to VP and inclined to HP such that the plane of it is an ellipse of minor axis 40 mm. Let's draw the projections. So we have been given a circle which is inclined at some angle with HP, which is not given to us, and it is inclined in such a way that the ellipse which is formed in the top view has my minor axis of 40 mm. So how we are going to draw the solution? So let's go to the teletop on this. Okay, so we'll first write down the parts that are given to us, as we always do. It's given. So the first point that is given to us is the diameter of the circular plate. Diameter of the circular plate is 70 mm, and okay, let's just move this. Diameter of the plate is 70 mm, and it is resting on HP. Okay, the second thing that is given to us is the plate is perpendicular to VP. That is obvious because it is lying on HP, so it will be perpendicular to VP and inclined to HP in such a way that the minor ellipse which is formed, the minor axis, the length of the minor axis is given as 40 mm. So first of all, we need to actually plot the circular plate on the planes, and then we'll have the general the view, the front view and the top view, and then we will draw the exact projection. So let's get on to it. First of all, the first step, as we always do, will be drawing the line XY. A straight line XY. Now the next thing that we are going to do is, now first of all we'll take diameter is 70 mm, so the radius would be 3.5 mm. So we'll take the radius equal to 3.5 mm, right? And then as it is resting on HP, the top view, that the top view would be a circle, and the front view would be a straight line, and the top view is below line XY as it is in the first quadrant. There's nothing given, so we'll take in the first quadrant. So we'll just draw the circle first. So this is the circle that is there. So I'll just make it dark with a sketch pen so it is visible to you. As I've drawn it freehand, so you'll find a little bit of irregularity, but just ignore it. Now the next thing that we have to do is we'll divide the circle into 8 parts. Now you should divide it by the normal method that is there. I'll just divide it directly so that we save on time. Okay, so we have divided the circle into 8 parts, and let's name them what we have here as A, B, C, D, E, F, G, and finally H. Right, now let's extend these points upwards. Okay, so we find these points, and as this is lying on HP, so these points will be on XY itself, and the straight line which is there will also be found on line XY as it is lying on HP initial condition. Okay, now let's name them. This is A dash. From A it is corresponding to A dash. Now this point corresponds to H and B, so the first point is B dash and the second point is H dash. Now C and G, so C dash and G dash. D and F, so D dash and F dash, and finally we have E dash. Okay, so this is it. Now what is given to us, that this is tilted in such a way that the minor axis that comes is of 40 mm length. So what we need to do is we need to draw two lines of which has a distance of 40 mm in this way. Say I've drawn one straight line and I'll take two endpoints. Say here we have taken 4, and again here I have taken 4. So this is 40 mm, and I'll join these two lines like this, right? And then what I need to do is I need to put this line here in such a way that it is between the endpoints are on these two lines and this whole length is occupied. Now here this diameter is 70 mm, hence this diameter is again 70 mm. So what I need to do is that point A will be remaining here, and using my projector I'll take 70 mm arc, and I'll just cut an arc on the other line. So I've taken 70 mm and I'll put my point here and I'll cut an arc. So that means that these are the two endpoints of this line, and I will just join them. Okay, so I've joined them. Now what I need to do is I'll just make it dark so that it's visible on the camera. Okay, so I have these two endpoints. Now I need to mark 1, 2, 3, 4 and 5 points on this. I already have these points. So this is A1 dash and this is E1 dash, right? Now I need to mark the 3 points which are there in between. How will I do that? I will put my point on A, measure the distance of A to B, and then cut an arc here. And now again from A I will G to C, I'll take the distance and I will cut an arc here, and from A again I will take F to D and I will cut an arc here. So I have all the 3 points which I'll just darken it up and so that it's visible to you. B1 dash and H1 dash, this is C1 dash and G1 dash, and this is D1 dash and F1 dash. Correct? Now from these points I need to drop down perpendiculars, parallel lines to these lines. Okay, now what is the importance of this? Now these lines have come from top, these lines will come from here, and the minor axis, so see this will be the minor axis, so the minor axis is this much. So these are the two, this is what, this is 40 mm. So my condition is fulfilled, right? So this is there. Now I'll just draw the intersections here, here, and here, finally here. So these are the points that I have obtained. Say what is this? This is coming from G and this is coming from G, so this is G. This is coming from H, again this is coming from H, so H. So similarly I have all the points marked, and which goes as, this is C1, this is B1, this is A1, this is D1, this is E1, this is F1, this is G1, this is H1. So all these points are there. Now I'll just use my sketch pen to join them. That is A. Okay, so I'm working. Okay, I'll use this. From A it goes to H, A, B to B, C. Use a smooth curve, D, E to F, G, H and I. So this green curve that has been obtained has a minor axis of 40 degrees, and this is the projection that is there, right? So this is what is given to us, and this is the solution of problem number 3b that has come to us. Okay, next is question number 4a. We have to define two things that are given. One is polyhedra and one is solid of revolution. Now these two are with related with the development of surfaces and the solids. So first say polyhedra. Now let's go to the definition first. A polyhedra is defined as a solid bounded by planes called faces. When all the faces are equal and regular, the polyhedron is said to be regular. Tetrahedron, cube, octahedron